Some people have problems, chemists have solutions. If you'd like to check out an interesting music video, I know how much you love these, you could go to that YouTube link. Polar versus nonpolar. Polar substances have a region that is partially positive and partially negative. This is noted by the Greek lowercase delta. And it has the delta sign either with a positive or a minus behind it. Examples are water, ammonia, acetone, SO2, vitamin C. And ionic compounds also have a negative and positive region. For example, sodium chloride, if you write it in its Lewis structure, Na plus and Cl minus, it's just missing the dots in there. And for solubility, to see if it dissolves in water, you do need to use a solubility chart. Examples of ionic compounds: silver chloride, sodium nitrate. Nonpolar. Nonpolar substances do not have a charge distribution of positive and negative. These compounds are 100% covalent. Examples: benzene, there's a benzene molecule; paraffin wax, maybe you've had your feet waxed before; carbon tetrachloride; cholesterol, hamburger; fat, look at that cat; vitamin E, like you might take in a vitamin E tablet; and rocks. Rocks are nonpolar, they don't dissolve in water, so they cannot be like water. That brings us to like dissolves like. Similar substances tend to dissolve in each other. Polar things tend to dissolve in polar, and nonpolar tends to dissolve in nonpolar. If you dissolve in something, you're miscible. For example, salt dissolves in water, so that those two things are miscible. If you can't dissolve in something, you're immiscible. Oil on water. Oil and water do not mix. Like dissolves like. I found a great website. You can go to this link and check it out about solubility. For example, if this boy were to eat this cotton candy, get it all over his face, a good way to get it off his face would be to use a cloth with water in it, since sugar is water soluble. And here's the great lava lamp of life. The globules in there obviously are immiscible with the liquid. Over here we have grease on your hand. If you're working on your car, your bike, and you get grease on your hand, water is not going to get it off because water and oil don't mix, but you could use perhaps some oil, some fat, some butter, and it would help get it off. Even peanut butter. And you see it raining here. It's a good thing that when it rains that it doesn't dissolve all the leaves. The leaves must be nonpolar since the water is polar. And on this website it has this great thing about nitrates, which are fertilizers. You can get nitrates from cows, from their waste. Farmers use nitrates to fertilize. Perhaps you use nitrates to fertilize your own grass. The downside of that is that nitrates go into the ground, and in the ground there is water, and perhaps water tables. It's water soluble and gets in the water. If you drink this water, you can get very sick. If you'd like a good animation of things that are polar, nonpolar, and dissolve and not dissolve, there's a Journal of Chem Ed link. So what dissolves and what doesn't dissolve? If you put acetone, which is polar, in water, do they dissolve? Yes. If you put ammonia, which is polar, and benzene, which is nonpolar, do they dissolve? No. If you put sodium chloride in water, will it dissolve? Yes. Like. Sodium nitrate in water, yes, they dissolve. Calcium carbonate in water. I know it's an ionic compound, but here we have to refer to the solubility chart, and chalk is not soluble in water. That grocery store lab keeps coming back to haunt you. Vitamin E is nonpolar. That means it's soluble in fatty tissue, which is not a good thing. It means it can build up and you may never get it out of your fatty tissue. Vitamin C, however, is polar. It's water soluble, so if you take too much vitamin C, you're just going to urinate it out. Rate of dissolution. Dissolution is dissolving, which is soluble. Factors affecting the rate. Surface area. Hello. So if you take a sphere and you cut it up into cubes, perhaps taking sugar and pulverizing it, you have a greater surface area and it will dissolve faster. If you increase the temperature, you can increase the rate of dissolution. And if you agitate or stir, you can also increase the rate of dissolution. Solution, a homogeneous mixture of two or more substances. The solvent is a substance present in the largest amount. For example, over here in this glass, the water is present in the largest amount. The solute is the thing being dissolved. This is either sugar or salt, and it's the thing that's in lesser amount. Aqueous solution is a solution in which water is the solvent. Miscible, substances that will dissolve in each other. Immiscible, substances that will not dissolve in each other. Here's a great density column of items that are immiscible. And here's the container of water and oil. They are immiscible. Ways to look at concentration. we're going to talk about mass percent, percent by volume, and molarity. And you can look at this great picture here of going from less concentrated to more concentrated. The color shows that quite well. Mass percent, the mass of a solute present in a given solution. The formula is mass of a solute divided by the total mass of solution times 100. The complicated part is the bottom. The total mass of solution is really the grams of solute plus the grams of solvent. So this is where I can make a tricky question for you. If I ask you just either the solvent or the solute, you'd have to do some algebra and make sure you follow your algebraic rules. So we're going to do homework number 5 and calculate the mass percent of 2 milligrams of calcium chloride dissolved in 0.0380 grams of water. The first thing we need to do is write down the formula. The formula is mass percent equals the grams of solute divided by the grams of the solute plus the grams of the solution. I abbreviate solution as SOLN and times 100. And then we're going to go, that equals 2 milligrams. That was the solute. Then we're going to repeat that down here because that's the solute again. And the solution was 0.0380 grams. We're going to change that to milligrams to keep everyone happy in the unit department. Times 100. Make sure you enter it in correctly on your calculator, and you should get about 5% calcium chloride solution. Percent by volume. Amount of liquid solute dissolved in a solution. A liquid and a liquid. The volume of liquids are not always additive due to differences in sizes between the molecules. So 2 mils and 2 mils doesn't necessarily add up to 4 milliliters. And you can think of pouring sand into a jar of marbles. The sand fills up the spaces between the marbles. And it is not additive. Formula, grams of solute divided by the volume of solution in milliliters times 100. So we're going to do homework practice number 8. And that says a hexane solution contains impurities, 5.2% by mass heptane and 2.9% by mass pentane. Calculate the mass in grams of each component, so all the 3 things present in 93 grams of the solution. Before I do this problem, I'm going to show you what your homework is, so I don't have to flip back to it. Your homework is worksheet number 2, and you do not need to do number 2 or number 4. So let's get on to the problem. So problem number 8. We know that mass percent, again, is the grams of solute divided by the grams total. And what we're looking for are the grams of solute. I'm going to rearrange this algebraically. The grams of solute, I'm going to bring that over there, is the mass percent times the grams total. So the grams of solute, we're going to do each of these individually. We're going to take the percentage and change it into a non-percent. So we're going to do 0.052 times 93 grams. I'm going to do that other number, 0.092 times 93 grams. And multiply those. That first one was for heptane, so we get 4.8 grams of heptane. And then the other one is 2.7 grams of pentane. And to get that last one, we're going to take the total 93 grams minus 4.8 grams minus 2.7 grams. And so what we actually have are 86.0 grams of hexane. And there's your answer.